Welcome to the deep dive. Today, we're diving into something that can feel pretty daunting: technical interviews for IT roles.
Yeah, they definitely can be. Doesn't matter if you're experienced or just starting out, they feel like a big hurdle.
Absolutely. It's that moment where you have to show not just what you know, but, how you think. That pressure, well, it causes anxiety.
For sure.
And that's why we've done the legwork. We went through like a ton of article stuff on common questions, how to answer, common mistakes, specifically for IT and software engineering roles. So, the mission for this deep dive: to pull out the key stuff, give you practical knowledge, and kind of demystify it all.
Right? Make it less scary.
Exactly.
Right.
So you can walk into that next interview feeling hopefully a lot more prepared and less stressed out. Think of it like your confidence cheat sheet.
And it's more than just memorizing answers, right?
Yeah.
It's about getting the principles behind the questions.
Yeah.
So you can handle whatever they throw at you because you understand what they're really looking for.
Okay, so let's unpack this. Our sources, they suggest technical questions usually fall into about three main buckets. First up, tools,
Ah, yes.
the specifics.
Right. What software, programs, technologies have you actually used? Programming languages, design software, maybe project management systems, CMS, CRM, all that stuff.
Exactly. Interviewers want to peek inside your technical toolbox. But like you hinted, just listing them, that's not really enough.
No.
They're really interested in how you learn them, your approach to picking up new tech.
That came up a lot. One big piece of advice was to talk about your thought process. Like, why did you pick Python over R for that one project? Explain the why.
Good point.
And also, show you're proactive. Mention related tools you do know, even if you don't know the specific one they asked about. And talk about how you learn at tutorials, company training, whatever.
That shows you're adaptable, willing to learn. Big pluses. Okay, so the second area is processes.
Processes. This is about how you work. How do you deploy something? What statistical methods do you use? What are the steps in your decision tree? Unit testing, UX frameworks, agile.
So less about the specific software, more about your workflow, your methodology, like how you approach problems.
Precisely. How do you ensure brand guidelines are met? How do you prioritize deadlines or handle feedback? They're trying to gauge your working style.
Right, and how easily you'd slot into their team and their way of doing things.
Exactly. Explaining the how and why of your actions is key here.
Okay, tools, processes. What's the third one?
The third is situational questions.
The hypotheticals.
Yeah. What would you do if
Architect.
scenarios designed to test your problem solving, your critical thinking in like a real world-ish context?
Okay, give me an example.
Things like, how would you figure out what users really need? Or what do you do with a massive, messy data set? How do you handle outliers? Debug a faulty update?
Or even like suggest improvements to your favorite product.
Right. Or managing budgets, explaining project plans, dealing with risk. It's broad.
And the crucial thing here, according to the sources,
Walk them through your thinking, step by step. The actual answer often matters less than how you get there. It shows off your analytical skills.
that makes sense. Now, here's where it got really interesting, especially for folks targeting, the big tech companies, FAAing and the like.
Oh, yeah. System design.
The Design X product questions, these seem intense.
They are. They push you to think big picture, architecturally. It's not about specific code snippets.
Right.
It's about designing systems that are scalable, reliable. Our sources had tons of examples, like designing a social media app, something like Twitter X.
Okay, so what are they testing there? Databases.
Databases, sure, but more
Yeah.
than that. It's about handling massive scale,
Mm.
tons of users interacting at once, keeping data consistent everywhere.
Okay.
You have to weigh the trade-offs between different architectures.
So if you get one of those Design X questions, what are the absolute must-dos?
Well, the advice was pretty consistent. First, ask questions. Lots of clarifying questions. Nail down the scope, the requirements, any constraints. Don't just jump in.
Okay, clarify first,
Yep.
then what?
Then sketch out a high-level design. Think about the main components, APIs, databases, maybe rough estimates of scale.
High level first.
Then, and this is critical, zoom in, identify potential bottlenecks. Drill down into specific components, then bring it all back together and check, does this design actually meet the original requirements?
Got it. Clarify, high-level design, drill down on bottlenecks, connect back.
Exactly.
We saw some other cool examples too, like designing a game, chess maybe, or even parking lot.
Yeah, the parking lot one is clever.
It seems like a way to test technical thinking on, like, everyday things.
Totally. It's a great way to assess object-oriented design skills. Applying technical concepts, users, classes, interactions to a physical system.
Interesting. And then there were the more classic tech ones, right? Like a URL shortener
Mm-hmm.
or a web cache.
Definitely. For those, things like high availability, keeping the system up, and scalability become super important. For a web cache, you'd need to talk about trade-offs like hash table size, data replication, how you ensure speed.
And for the URL shortener, maybe more focus on resilience, business goals.
Yeah, exactly. Making sure it works reliably and meets the underlying need.
The range was pretty wide. We saw examples like designing autocomplete for search, an API, a messaging app.
Online file sharing,
Yeah.
like Google Drive or Dropbox.
Right. E-commerce stores like Amazon, ride-hailing apps like Uber.
And what's cool is how these different problems actually test similar core principles. File sharing. You're dealing with storage, security, collaboration, sync issues,
Ride-hailing.
real-time tracking, matching algorithms, payments,
Yeah.
but still fundamental system design challenges underneath.
And it's not just these giant design problems. Our sources also mention knowledge questions, maybe for more junior engineers.
Yeah, testing foundational understanding, things like explaining caching or what an API gateway does or the difference between SQL and NoSQL.
So more direct checks on basic building blocks.
Exactly. You might even get these in senior interviews, just to check your understanding of why you made certain design choices.
And just to show the scope, the sources gave actual examples from big companies. Google asking about YouTube design, Meta about Instagram, Amazon about distributed cache, Microsoft about Google Drive.
Uber's heat map. Apple designing a smart elevator system.
Wow. Okay. It really shows the breadth you need to be ready for, especially at that level.
It really does.
So with all these potential questions flying around, what are the absolute must-know technical concepts that kept coming up in our sources?
Okay, yeah, there were definitely some recurring themes. Consistent hashing was one.
Consistent hashing. Remind me.
It's basically a smart way to spread data evenly across servers and, crucially, manage things smoothly when you add or remove servers. Think of it like assigning seats at a round table with a rule, so if one chair is added or removed, only the immediate neighbors are really affected.
Okay, so efficient data distribution, especially when things change. Got it. What else?
The API gateway, super important. It's like the front door for all requests coming into your backend services.
A single entry point.
Exactly. It handles routing requests to the right service, deals with security, composition, monitoring, maybe even load balancing, like a concierge for your whole system.
Makes sense for complex systems. Okay, what about data storage?
Crucial. Understanding SQL versus NoSQL. The differences in structure, fixed schema versus flexible, how they handle transactions, A/C guarantees versus eventual consistency, and how they scale vertically versus horizontally.
And knowing when to use which, I assume.
Absolutely. That's a key design decision.
And for performance, caching.
No, it's caching. Knowing why we cache speed, reducing database load, and the different strategies, cache aside, right through, right back.
And to kick things out of the cache when it's full, like LRU.
Yep. Least recently used, least frequently used. Understanding eviction policies is part of it.
Okay. We also saw row versus columnar databases. That feels a bit more specific.
It is, but it's important for certain types of work. Row-based is generally better for transactional stuff like processing an order. Columnar is often better for analytics, where you're querying large amounts of specific data points across many records. Knowing the difference matters for performance.
Gotcha. Another one was CDN Content Delivery Network.
Right. That's all about speed for the end user no matter where they are. It's a network of servers spread out geographically, holding copies of static content like images or videos.
So the data travels less distant.
Exactly. Reduces latency, improves load times, boosts reliability. Big deal for websites.
Okay. And then there were different ways apps talk to each other in real time.
Yeah, understanding the trade-offs between long polling WebSockets and server-send events. When do you need two-way communication versus just server pushes? Which is more efficient for your use case?
Good point. And as databases get huge, how do you manage them?
Data partitioning. Breaking large databases into smaller chunks. You need to know about horizontal partitioning or sharding, vertical partitioning, range partitioning, hash partitioning, different ways to slice it up for better performance and manageability.
And within a single database, speeding up searches.
Database indexes. Essential for fast data retrieval. Knowing what they are, the different types like B-trees or hash indexes, and crucially, the trade-off they speed up reads but can slow down writes.
Ah, the trade-off. Good to remember. And finally,
load balancers. Can't forget those. Spreading incoming traffic across multiple servers so no single one gets overwhelmed. Key for availability and handling load. Hardware ones exist too.
Okay, that's a solid list of core concepts.
Yeah.
Super helpful. Now,
Right.
let's talk about the other side. Mistakes. What are the common ways people trip up in these interviews? The sources must have had plenty to say.
Oh, definitely. Hiring experts from all sorts of tech companies weighed in. One of the biggest, most frequent mistakes, not asking clarifying questions.
Really, that seems basic.
You'd think so, but folks at Facebook, Kensho, CPO, Guru, VTS all mentioned it. Ask early, ask often. Make sure you really understand the problem and any edge cases before you dive in.
Right. You can't solve the right problem if you don't understand it. Okay.
Making assumptions without saying them out loud. Uber flagged this one. If you make an assumption, state it clearly. Okay, I'm assuming we only need to handle logged-in users for this feature. That way, the interviewer knows your reasoning and can correct you if needed.
Good practice. Avoids going down the wrong path based on a bad assumption.
Exactly. And this next one was huge, echoed by companies like Def Method, MongoDB, Guru, BlackRock, VTS. Not explaining your thought process.
Just staying silent while you think.
Yeah, or just jumping to a solution without saying how you got there. You need to verbalize your thinking, even if you're unsure. Okay, my first thought is maybe approach it this way because it lets the interviewer follow along and see how you problem solve.
Even if you don't know the answer immediately.
Especially then. Clyde mentioned this. It's better to say, I don't know the exact answer, but here's how I would try to figure it out, than to bluff or clam up.
Honesty and process over bluffing. Got it.
Automatic mentioned not explaining how you arrived at the final answer. Show your work, basically. Detail the steps.
And when talking about past projects.
Not being clear about your specific contributions. Logman Capcio hit on this. It's easy to say we did this, but they want to know what you did. What was your role, your impact, especially within the context of the software development lifecycle.
Focused on the I, not just the we. Makes sense. What about prepping beforehand?
Big mistake. Not doing your homework on the company. Waters and Smartsheet pointed this out. Research their products, their tech stack, their culture. It helps you tailor your answers and ask smarter questions. Shows you're actually interested.
Demonstrates initiative. Okay, what else?
Miscommunication. Afterpay and Veracode mentioned this. Be clear, be concise, listen actively to the question before answering. Empathy helps too.
And for coding parts.
Mural. Flagged not clearly stating your preferred coding language up front for live coding. Simple thing, but avoids confusion.
Yeah, easy fix.
Bristol-Myers Squibb and CIPCO emphasize being unprepared to discuss specific examples of your technical expertise. Have concrete examples ready, tied to the job description ideally. Be ready to explain the details and your role.
Don't just say you know Java, show how you use Java to solve a problem.
Exactly. And related to that, Clearis Commerce noted the mistake of not tailoring your experience to the role. Connect the dots for them. Show how your background fits their needs, using examples relevant to their tech stack if possible.
Right, make it relevant.
Also, not taking a collaborative approach. Netscope and VTS mention this. Especially for design or problem solving, interact with the interviewer. Ask for feedback. Show you can work with someone.
Don't just treat it like a test you take in silence.
Right. And conversely, SeatGeek and Procore warned against rushing into problem solving. Pause, understand the question, ask those clarifying questions before you start coding or designing.
Take a breath. Think first.
For remote interviews, a simple but crucial one from Game Changer. Not testing your equipment beforehand, bad connection, faulty mic. It derails things.
Basics matter. What about answer length?
It's a balance. Autodesk warned against over-explaining. Be concise. But PagerDuty pointed out that answers that are too short might not give enough detail. Find that sweet spot.
Tricky balance.
Other pitfalls mentioned, responding without thinking. Health first. Trying to bluff when you don't know,
I saw.
to be honest. Not asking the recruiter for guidance beforehand about the interview format. Procore said do this. Not thinking out loud before analyzing code. VPS again. And a big one. Not preparing for behavioral questions using the STAR method situation, task, action, result. Unstoppable Domains and Shekin Code both flagged this.
STAR method for behavioral questions. Yeah, that's key.
And finally, just weak overall communication skills, as Veracode put it. It can really undermine strong technical skills.
Wow, that's quite a list of potential traps. It really drives home that it's not just about the tech.
Absolutely not. It's communication, preparation, problem-solving approach, the whole package.
Okay, so knowing all that, what are the most important, actionable things our listeners should do to prepare effectively?
Prep is everything. First, really dig into those job postings. What skills are required? What's recommended? Make a list.
Okay, know the target.
Then, practice answering questions out loud, both technical and behavioral. For behavioral, Seriously, use the STAR method. It structures your answers so well.
Situation, task, action, result. Yeah, helps keep things clear and focused. What else?
See a tool or process you don't know well. Watch tutorials, read docs, learn the basics. Don't go in totally cold. Research the company thoroughly, products, tech, maybe recent news.
Shows interest, helps tailor answers.
Prepare your own thoughtful questions to ask them. Shows engagement. On the tech side, practice common data structures and algorithms. Use sites like LeetCode or HackerRank.
Get those coding muscles working.
Consider doing mock interviews. Get a friend, a mentor, someone to grill you. It helps simulate the pressure. If it involves whiteboarding or virtual drawing, get familiar with the tools.
Good point. Don't want to fumble with the tool during the interview.
And reiterate those key points from the mistakes section. Focus on understanding the problem first. Don't jump to solutions. Articulate your thought process clearly as you go. Be ready to discuss past projects, focusing on your contributions and the tech involved. And definitely review those fundamental system design concepts we talked about.
That's a fantastic checklist for preparation. So bringing this all together, what's the final thought you want to leave listeners with?
I think the main thing is, technical interviews test more than just technical knowledge. They're looking at your problem-solving skills, how you communicate, how you approach challenges you haven't seen before.
Right, it's holistic.
Exactly. And solid preparation is really the best way to showcase all of that effectively.
So, as you, the listener, think about all this, maybe pause and consider, which of these points really hit home for you? What's one thing, maybe two, you can do right now to improve how you prepare for your next technical interview?
Yeah, maybe it's practicing explaining your thoughts out loud. Maybe it's diving deeper into company research. Or maybe it's time to brush up on consistent hashing or API gateways.
Whatever it is, take that step. This has been a really insightful deep dive. Thanks for joining us.
And definitely explore those resources further. The company-specific advice, the system design fundamentals based on the roles you're targeting. Good luck out there.